Everyone still fresh? Nice. That's good to hear, at least it's in the morning, so you should be. My name is Max. I'm talking about this topic today. We are seeing, we try to build a picture on what you need to build complex applications. The point here is complex. If it's not so complex as displayed here, just leave parts out, especially A2A. So if you don't need it, don't use it. But, so much. For me, I'm a developer / consultant at Thinktecture. We are specialized in building business applications with .NET and web technologies, mainly Angular, and also generative AI since a couple of years now. I started with machine learning in 2015, building an automatically extraction pipeline for these weekly prospects, Wochenanzeiger, etc. And what I did was use machine learning to categorize them, to building groups of interests in products that were displayed and then make them searchable by vector database. So, or comparable. If you're searching for margarine, you also find butter, at least at some point in this search. That has nearly nothing to do with what we see in modern generative AI applications. Those are mainly large language models, maybe small language models, and vectors. So vector databases, tokenization, RAG systems, all based on vector databases or vector representation of words. So what's the difference between back then and now? Now they are agentic. And because they are agentic, we have to consider, no, does it work? Yes. We have to consider a few parts. We have to consider how to provide tools or functionality to those agents that we are using, how to interact with those agents, and how to display the results of those did they move something? I don't know. How to display the results of those interactions to the user, and also how to orchestrate complex tasks, long-running tasks to other agents if they are on a different system, or if they should be on a different system, or if we don't want to expose anything but a chat interface from agent to agent. So let's start with the Model Context Protocol. Those basic building blocks, those basic tools that consist or that are used widely in modern applications. If I say applications, I'm not exclusively saying developer tools. Who of you is a developer? Nice, a lot of hands. Who has developed at some point in his life? Anything. Those questions I'm going to ask are not exclusively. You can just keep your hands up. So we are doing some sports in the morning also. So, okay, a lot of developers here. Who has experience with AI development or generative AI? Nice. So at least all of you, or most people, should have an idea of what a tool is, right? Good. Who has developed its own MCP? Fewer hands, but still a lot. Who found it easy? The same people. So everyone, or nearly everyone that developed an MCP found it easy. And that's for a reason. It's made for developers. So you can think of an MCP as an USB-C plug, if you mean so. You have a universal tool, or nearly universal tool, that developers love and plug in every system that they find. And if they find it useful, they plug another MCP in there. So they are not exclusively one-to-one connections in the system. There can be multiple MCPs, and like in USB-C device, those devices can't directly communicate with each other. And there's some layer of security in there and authentication, but still it's a USB-C device. Who would plug an USB-C device into its own machine that he found at an airport. Perfect. Why does everyone just plug an MCP into their system? So one part of the security concept with those MCPs is think before you use it. And that solves nearly 80% of its problems that were there in the past. So next slide. Okay, now I know why I'm confused. I see the live stream here, and that's delayed, so that's better. An MCP or an application with an MCP is defined by 3 parts. There's a host, a client, and a server. And the host and the client is not the same. The host application could be, for example, a Claude, your IDE, a web application that uses an MCP, or even something different, else differently. An CLI application can also be a host. However, in these hosts, there must be a client that connects to different servers, and each client is connected to one MCP server. So those clients or those MCP servers can't communicate with each other. They are isolated from each other, and they don't know anything about it at all. Only the client knows the connections and what there is and can orchestrate and manage and do stuff with them. And I think that's a pretty neat concept, because at least in theory, they shouldn't influence each other. Who has experienced who uses more than 3 MCPs in their application, in their IDE, whatsoever? Okay, who uses MCPs at all? Okay, so you all use 1 or 2 MCPs. Who uses a search client? Web search, context 7, something like that? Nice. Who uses MCPs for development? Nice. Who uses MCPs in other apps? Okay, there's a mismatch between people who use them in development and who use them at all. So let's see where we get with that. When we are using MCPs, we find that if we add too much context, or if we add too many MCPs to an application, the results degrade. So whoever used, for example, Root code or Klein in VS Code and added, I don't know, 3 MCPs, everything's fine, and then he added the GitHub MCP with all its tools, found relatively fast that the answers got worse. So that's because there's a context window. And I'm getting ahead of myself, but we have a lot of topics to cover today. So why should we care at all? I mean, that's all the old developer principles that we know. Don't repeat yourself, keep it simple, stupid. Don't standardize your usage of tools in different ways or where you use it, and make your system resilient to changes. So isolate stuff, expose clear RPs, etc. And all that is handled by the MCP protocol. Or you can also express it that way. Before MCP, before those toolings that are emerging in the recent month and maybe over the last 1 or 2 years, every connection that uses, every AI application that uses some different tools or database connections, documents, FAQ, whatever, had to manage its own connection. By now, I should only use the keyboard, that's easier. By now, with the introduction of MCPs in the system, the MCP handles those connection management for us. So instead of having by 6 applications at least 9 connections, we now only have 3. And that's a reduction in complexity. And all those systems and all those protocols I show today are basically that. Reducing complexity, not in development, but in integration, right? So, the MCP, as mentioned, solves the problem by building it once, connecting it everywhere. If you provide your MCP via HTTP or via locally, that's pretty easy. It's open source and vendor neutral. Every client that I know of by now supports MCP or MCP2 sets and other features of that in some kind of way. And it's based on proven patterns. Who knows NeoVim or Vim or whatever? I love it. Ah, nice. More hands than last time. So, who uses it? Still more hands than last time. It's getting traction. Who uses VS Code? Nice. So, the most of you should know language, LSP, Language Server Protocol. Basically, VS Code introduced a system by extracting its programming language handling, symbol finding, auto-completion, etc. into a server. And now that pattern is used by nearly every language and by most of the IDEs and text editors out there. MCP basically had the same idea. Why rebuild it every time if we can extract it and expose a simple API for it? And by simple API, I really mean simple. This example. In my development time, I always have to query some JSON. So create some Pokemon trainer JSON. So I always have to query some JSON. And because it's an LLM, it basically saw those JSON at some point, and I get a nice answer. And then what I have to do with it, I have to query it for something. And I can use to, and to not repeat myself, I can reuse prompts, very explicit prompts that I wrote at some point, and just plug them in here. That's provided by an MCP, for example. So yeah, it's the pointing. Okay. Yeah, that's okay. And I added a query or a prompt here, and now I can say, write JQ query to get all trainer names. And now it knows how I want my JQ queries to be written. If they get complex, introduce functions into them, introduce patterns like, who knows JQ? Okay, awesome. If you don't know it and have to handle data on the CLI, look it up. It's awesome. So it's basically a programming language to query JSON. And this looks good. It also does want to run it directly. And it asked me if it should be run. Yes, allow it. And now it runs those JQ queries via an MCP that I introduced into the Claude application. And I use this MCP or this tooling I created for myself in Claude, in my VS Code, on my CLI. If I don't want to open an application, I have a simple command line interface for running JSON files with questions. And then the agent basically creates everything for me. And with that, it created the prompt. I hope that's readable. It should be now. It created the prompt, the result, and a really short explanation. So that's fine. I also can use this one directly. We can, for example, use the inspector tool that comes with it and see everything that is in here. Okay, it died. I have to restart it. We do it later. And with this basic pattern, by introducing those configurations in our tools, we can use it everywhere. And the full workflow on how those host applications use those MCPs is they initialize a connection via a provided URL or CLI call. And it's not really important what there, I tell you it anyway. Then afterwards, if they have the connection, including authentication if necessary, then afterwards they call a list function that lists all those resources, prompts, tools, whatever you name it, what the MCP offers. And afterwards, it adds it to the context of the LLM file. And the LLM then can just call the MCP via tool calling, like you know it anyways, and can handle the responses for you. The nice thing with that is the MCP introduces knowledge and domain knowledge, and can provide advanced tools to hydrate your context at some point with pinpointed information, and can summarize tasks or multiple steps into a simple task if you know that's a simple workflow. And I mentioned them already a couple of times. Oh, I have to really speed up. Sorry for that. We will run now through those topics. So there are different features in MCP. Tools, we saw them. Resources are basically access to databases and everything that you want to expose via an API that the agent can load or the application can load at some point. Prompts, we saw those earlier. And elicitation. Who knows what elicitation means? I mean, it's a very nice word for a very simple concept. Elicitation is I ask the user. So if an MCP or has a tool call decides that it needs more information at some point, it can send an elicitation, and the elicitation is answered by the user or directly by the agent. The same goes for sampling. If the tool decides or if the agent decides I need more data on this, the tool can ask the agent to generate more input or sample text based on a request that it sends. Elicitation sampling is nearly not supported by now, at least not in official tools. Prompts and resources are available but are rarely used automatically. You can add them yourself. And server composition is basically you have one MCP, and this one MCP can load multiple MCPs into its context and expose them via its own API. So you bundle stuff, and then you can decide if you want to prefix those MCP tool calls, resources, etc., or if you just want to expose them by yourself and you're pretty sure that you're not conflicting with their stuff. There's also some kind of user feedback, progress report namely. The MCP can send responses to its callee and saying, yeah, I'm working on it, that's my state, and I also can give you a progress from 1 to whatever number you want, but it has to be a number. You can't say I'm in progress of 3. You have to send something like I'm in progress of 3 of whatever. And then the client can decide if it supports to display those progress. Hint, it's not very commonly supported. So, and since there are basically only tools are supported everywhere, resources and prompts are supported, so they are known and are used in some kind of way, but the MCP community is also eager to introduce new features like MCP UI. Basically, MCP UI is what I show you later with AG UI, but on steroids. With AG UI, you have a protocol and create your own components. MCP UI aims that the MCP delivers you the components it needs to display its information or tool call results. For example, your Amazon shopping cart, your to-do list, your to-do app can display its to-do items in their own style, so the corporate identity is not lost. All those features are used, for example, for grounding. You can, with an MCP, you can provide a centralized system to ground your LLM application with information it needs to handle all those requests. It provides context hydration dynamically. At some point in the future, via call, the LLM decides I need more information, and instead of searching or asking you, it can directly access the MCP and search the web, search your internal business systems, whatever. I mentioned the feature support. Even who knows Anthropic? I mean, you should all have heard of it. Anthropic are the masterminds behind Claude, Sonnet, whatsoever. And they came up with the idea of MCP, and even they are not supporting every feature of it in their own applications. So it's really rapidly evolving. As mentioned earlier, MCPs can kind of overflow your context so that your answers get worse. You have to limit your usage of MCPs, and if you're developing MCPs, limit your description and stuff that you're exposed to the bare minimum to make it work really good, but not overexpose and over-describe stuff. So even it helps your tools to be better called, it worsens the whole application. There are workarounds for it. For example, dynamic tools. When the discovery phase asks for tools, you can just send one tool and that's get more tools. So then you describe your MCP, what it does with the get more tools, and if your MCP is used at some point, those get more tools can be called and the list of available tools is updated. That also works with authenticated user, non-authenticated user, what are the rights, what are the access rights, what's the use case that he's talking about. So tools are the list is dynamic and you can send update list requests to the client. For now, async tools are supported. It's an HTTP request. Of course, it's async. But what's not supported is long-running tasks that don't give you direct feedback. I'm talking about something like a research agent. I mean, we all use them. Basically, if I ask Perplexity, Claude, whatsoever, research these topics, it sends one agent going for web pages, one agent going for summarizing those web agents, and then has more specialized agent in there to combine everything together. And you don't know how long they run. It can be a couple of minutes, it can be direct access, it can be hours, days, whatsoever. So you have to be, and I think in this context means I send it and I don't expect a direct answer. Instead, I can go in there at some point in time and get my answer. So that's async tools in this one. Also, for the context overflow, code execution. That's a really hot topic that came up the last couple of weeks, maybe 1 or 2 months. Code execution is I don't expose tools like get data, get user, query user shopping cart, whatsoever. Instead, I provide a description of tools available and how to call them. So I have this tool, get context, with these parameters, and I support Python. And then the LLM can write code with your tools that you describe them via doc or programming docs, whatsoever, and you execute this code in your system. So your code executioner. And what this does, it reduces the context because you don't need all tools. It reduces the round trips because the MCP or the system doesn't have to call user data, shopping cart, whatsoever. It's all in one go. And also you can query or limit something like I only need 5 results. Then that all can be done in one go. You offload complexity and context size into the LLM task to tell you what you should do and not what you can offer. So much for MCP, and we are right in time. Questions so far? Yes? So the question is, if I understand it correctly, for code execution, if it's better to have one big execution or better to have multiple tools for smaller code execution?
Instead of doing the code execution as
Okay. I would prefer code execution because it's more complex to have a server for those execution. You have to sandbox it, you have to make it secure, etc. So I would really just offer it for complex tasks that require multiple round trips and are and can be really improved through flexibility. Okay. So next up, A2A. Who heard of it? Nice. Who has used it? I expected that. Who liked it? One hand. That's different than MCP. So, and that's mainly the issue. You really must use it not that often. You can, of course, but what A2A tries to give you is a standard to enable a secure communication between different agents. And these communications is across different frameworks and platforms or even businesses. So the agent talks to another agent like you talk to another agent or human or whatever. It's not the A2A protocol is not exposing tool calls, but exposing a description of a remote agent with its supported features. It was invented by Google also this year, I believe, 25. It's still 25, yes. And around the mid of this year, there are also different approaches to this, like ACP by IBM. But ACP is by now included in A2A. So they just took it and said, yeah, we're the boss now. And then they gifted everything to Linux Foundation because at least in some points, Google is still a good guy. It's supported widely because it solves a very common problem. I mean, research agents, I just mentioned them. That's what this is for, to orchestrate different complex tasks that need specialized handling across multiple systems in different domains. And then you're at a point where you can use it, or where you can think of using it. And what it does, I mean, I just took it from the protocol list. It's right there. And also, let me read it to you because it's not that good readable. Organizational or technical boundaries. That's the point when you should think of A2A. If you just need to orchestrate different specialized agents and you have control over them in your system, maybe you don't need A2A, you just need an orchestration tool like Agno or Marschall AI provides. You can there put different agents into a system and teams whatsoever, and then the Marschall AI or Agno agent OS decides and handles all those orchestration and when to use what agent. Of course, since it's created by Google, it must use HTTPS for deployment at least. In development, it's not that hard. It supports nearly or basically all important authentication and authorization protocols. And it's still in your responsibility, if you write a server, to authenticate every request. I mean, just because it's supported, just because I can put a middleware simply in there, I still have to make sure that the user is actually allowed, or that the agent of the user is allowed to use this agent for the tools that it's using. It was created with goals still to make stuff easier. You saw you have those diagrams from the start still in mind, where I draw 9 lines and made it to 6. The n times m problem becomes n plus m. So to make it simple to integrate stuff. And this is this here. They are isolated, they are discoverable via a well-known endpoint, and they are made to exchange data. How do they do that? How do they do that? Yeah, that's my point. They provide you by now common way server sent events. We know them by MCPs, JSON RPC, also MCP, and reuse HTTP responses if server sent events or WebSockets are not supported. All those tools, all those protocols will appear again today in AGUI. So, and by that we have also to discuss who's talking to who. We have a client agent, and remote agents. And all those remote agent and client agents are talking to each other via a very loose coupled information. The remote is exposing agent cards. It is exposing agent cards that are read by the other client, and that with that cards it can decide what is the endpoint, how to call it, what are the tags, and how to use them. But since it's a very new protocol, not all clients that use A2A remote server support automatic differentiation between when to use what other remote agent. Most of the times you write your own workflow, some kind of, when you know, okay, I have this result, I have this request, I have this tool, and this tool calls another agent, remote agent. By now, some frameworks provide you an automatic way for it, like Agnos with its teams or Mastra AI, where they automatically orchestrate your tool calls and requests to the most fitting agent to handle it. One of those frameworks is the A2A protocol itself. It provides a middleware that can be plugged into their UI agent, in their client agent, that handles those calls for you. Before we are diving deeper in those concepts, I show you a demo of it. So we need this one later, this too. This, for example, is an agent card, a very simple agent card with Pokemon data. It's an agent that's written in fast agent with a simple function call, expose A2A. And then I provide this agent data that can be used by any application, can be read in, and then be used further. They are also exposing a chat interface that we are skipping for now. And then there's also an inspector for it. This inspector specifically runs here. Who has seen Copilot Kit? Okay, Copilot Kit is a framework that uses AGUI, and they have announced a partnership with Google, with Google and the ADK that they want to expose stuff together. And that's the demo that they came up with. But plan a trip for me to, where should we go? Any idea? Barcelona. Barcelona. Probably there's a typo in it anyways. And what it's doing now, that's the agent system is running on my system. I have to make it smaller. What it's doing now, it's asking me for more information, how many days, how many people, premium, why not, and make it 4 days. And then I can ask it to send a trip. And what you're seeing here now is the orchestra agent is sending the request to the agent that plans the trip, the itinerary agent. And it's displayed very beautiful to me, what is happening under the hood. So human in the loop, I get asked questions, I can specify even more, and then the data is displayed here. And all those updates here are handled under the hood for me by the protocol A2A middleware from AGUI that's plugged into the front end. And hopefully we can still see it. And if there's a request, reach out to create a I try again. So it died again. So, but what I wanted to show you is that if there's a request, we see all this data that is passed between those agents. And also in here, we see that the data that is sent back is just a streamable update. So every request is one message, and the update, messages, tasks, etc. are streamed back. That is the result, what is possible with it. The underlying agent card is valid. The underlying interfaces for that are, for example, this is the real agent card of the itinerary agent that we saw that plans a trip. So it has a very small description, very distinct, and skills that it can do with questions how it should be asked to do this stuff. And if I asked it something like, hi, plan Frankfurt, I can see my message, so the protocol that I'm sending. And what we can find in here is the method that I'm using. I'm sending a message via a stream or expecting a stream back. And with a context ID, so I can wrap future messages into the same context and parts that are my actual message. There can be multiple parts, and I can receive multiple parts back. So what I receive back is a message, again with a message ID, and parts again. Parts are the answer or the basic building blocks of these protocols. They are text parts, data parts, image data parts, and media parts, and also an ID. And if we use everything of that, we come to that. We have agent cards. We send a message to an agent that in return creates a task, a long-running task for me that I can come back and poll or expect a stream of updates on. Message are the way how they interact with each other, and messages consist of parts and tasks consist of parts, and everything is wrapped into an artifact or artifact ID. Artifacts are the context. And artifacts here are the end result of a task. So if I send it, do something for me, it creates a task and sends parts or updates parts in this task, and at the end there's an artifact. And when the artifact is there, it's done or it failed. One of the other. So we saw an agent card, we saw a skill. I talked about the task and also that these are the core principles. And we also saw how those tasks are identified in between runs via these IDs. And if you have a follow-up of a task or a message, for example, generate a boat in green, and afterwards to say generate make it blue, since the agent is stateless, or should be stateless between runs, it still has a database, or else those artifact or IDs wouldn't be helpful at all. It can reference those and update the request you made earlier and create, of course, new IDs for messages, but the context ID should be the same. All those complex interactions between each other is really hard to grasp when you start it. Even if you have those perfect demonstrations that we saw earlier, it's still hard. Because what they don't mention to you, or what rarely exposed, how the actual orchestration between agents in those A2A frameworks work. All demonstrations of that are workflows. I get a tool call, and then I decide, or I create a workflow or a lang graph or whatsoever that calls this distinctively agents that I came up with how it should work. But what's possible also, what we saw earlier, is that you don't have to define those edges, those workflows, but can use the tools that are provided by the protocol for you. So this is the actual orchestration of the demo that we saw earlier. Or better, we start with the orchestra. So this is the agent that orchestrates what tool should be called. It has a very long prompt, but if you scroll through this, okay, there's an agent exposed, but it doesn't know any other agent. It's not linked directly. Instead, there's a middleware created. And this middleware accepts this orchestration agent that we just saw, and the other agents, and then has informations on how to create or plan the trip with these agents. So that's a smart orchestra, I would say. And how they are connected, basically, you just use the URL that your agent is running on, and from there on, it loads the agent card, loads the endpoints, the skills in there, and knows it can work with it. So, key takeaways. It's open. Everything I showed today, at least the protocols, is open source. You can use it. They are widely supported. The libraries of those protocols are really good. The middleware agent that we saw is in the AGUI protocol package of TypeScript. So they are really intertwined with each other. It's a whole stack of building applications that are single protocols, but they are most powerful if they are used together with each other. And by that, we can take a look at the agent user interaction protocol, AGUI. Oh, God. We have 3 minutes left. Do you mind if I need 5 more? Perfect. So, AGUI is open, lightweight, event-based protocol. And with event-based, I really mean event-based. The problem it solves is that common interfaces or common ways to communicate with UI and servers, or nowadays agents, is HTTP request, REST RPs, for example. Or yes, there are some streaming RPs, there are some dynamic updates, but most cases and most ways an agentic application is started is request response, HTTP. And that's not good because we don't work this way. We are not sending something if we are dealing with an agent. We are expecting updates. Like, I moved it to another agent. I orchestrated. Here's the update. I need feedback of you. And managing all that with HTTP request is possible, but it's very cumbersome and hard. It's really, really hard to create dynamic UIs. And by that, I mean, for example, this is an app I created for myself to train my dog. Create a sit exercise. Typos are not that important. And what it gives me tool calls update. This application is 3 years old, or 2 to 3 years old. So the difference here is everything that you see is handled in the client. So the tool call or the communication is handled inside the client. If I go into the last tool call, request, I can see there are contents, get new ID, there's an assistant that calls a tool, and this tool is available in my UI, etc. So I don't have to think about communications with servers or sending updates because I own everything. The next step would be something like this. Let's go collections, create a new one, create a form to collect speaker data, paste, generate. So it generated this form for me and I get a preview. That's also nice. That's wrong. And again, here, that are kind of nice demonstration UIs that we use that demonstrate how an agent can interact with your application. Navigate to all speakers. It can navigate, it can update the form, it can fill out the form for you. Everything is possible, but still everything is handled in the UI. But what happens if your UI is not powerful enough, doesn't have all the tools that you need to create those stuff? Then you need the AGUI protocol. And it is also widely supported. Every major framework for agent or agentic system supports AGUI because it's that simple to support. It's based on events that are sent and streams that are accepted. And to create an app that uses AGUI with your existing agentic app, it's just one line. Basically, every example that I found, it's just one line for the basic support of it. And also here, to AGUI for pedantic agents. I mean, that's neat. And what they expose then for you is an endpoint that sends events updates. We have seen that. That sends events update at least 16 standard events. Text message started, text message update, delta updates, tool calls, and everything is handled through callbacks of those messages, and even state synchronization is handled through the protocol. So you don't own your state anymore, the protocol owns your state anymore. With this, it's very simple to dynamically update the state of your running agent at some system or A2A system, as long as the client supports the A2A protocol. And even though everything is streamed and events are supported, only messages are coming in multiple events or streams. Everything else is start, event end, or end. So, state management, we talked about it. And if we saw those dynamic UIs earlier where the chat knows about the UI and the events that are sent. If you want to handle UI elements like we saw earlier, there are two ways. You can either expose those AIs via an interface or a tool call, and then the agent calls a tool that is your UI and you're responsible of rendering it if you're doing it yourself. Or Copilot Kit, there's an API for it to just say, this is my AI. Copilot Kit is a company behind AGUI. They also provide a very good React framework, and they also support or kind of support Angular and other ones, but they are in development and beta status. They are broken, that's why I can't demo it right now. Again, when should you use it? If you need real-time updates, not in a POC. You don't need real-time updates in a POC when you develop it for yourself or develop it for someone else to demonstrate it, but for the user that doesn't know what's under the hood, you should consider giving it real-time update to enable it to feel to be part of the system. And that's mainly the issue that is solved, to include the user into your system via UI interaction with your agents. And with that, you can find other included links to all those things that I've shown today. And with that, I'm done with a slide overlay. Sorry for that, and thank you for being here.